This is section 2.2, example number 2. So we're looking at, let's see, part A. So we're trying to decide whether or not each correspondence is a function. So part A is the correspondence that assigns to a person his or her weight a function. And we're to assume that the first part, so the person, is the domain, and the second part is the range. So person to their weight. So I'm going to write down a couple names here. Let's see. So Ruth, Alexander, Michael, and Carrie. Say. And then let's see, let's write down some weights for them. Say 20, 110, 170, and 130. And let's say Ruth weighs 130, Alexander weighs 110, Michael weighs 220, and Carrie weighs 170. Okay? So now remember the definition of a function. A function is a correspondence such that for each member of the domain, so for each possible input, there's exactly one possible output, or there's exactly one member of the range. So we'll go down the list and check to make sure each input has exactly one output. So Ruth has exactly one weight, 130 pounds. These are all in pounds. We're in the US, so Ruth is 130 pounds. Okay, that's one possible output. Alexander, 110. That's one possible output. Michael, 220. One possible output. Carrie, 170. One possible output. So each possible input has exactly one possible output. So this correspondence is indeed a function. So yes, for part A. All right, moving on to part B. Part B, the correspondence that assigns to the numbers, this first part is the domain here, the numbers -2, 0, 1, and 2, each number's square. So the square of -2 is, think about it for 2 seconds while I have markers here. Square of -2 is 4. Square of 0, 0. Square of 1, 1. Square of 2, 4. Okay. And actually, we don't need to repeat 4s because that's the same number there. Okay, so -2 has 4 as an output. 0 has 0 as an output. 1 has 1 as an output. And 2 has 4 as an output. So then we need to double check. Does -2 have more than one output? No, it just has 4 as an output. How many outputs does 0 have? 0 corresponds to 0. Great. 1 corresponds to 1, and 2 corresponds to 4. So for each of these, there's exactly one output. That means that, yes, this correspondence is a function for part B. Okay, part C here. The correspondence that assigns to a best-selling author the titles of books written by that author. Okay. So let's think about this for a second. Let me come up with some authors and books real quick. Okay, here we go. I found a list of some of the books by Toni Morrison and by Alice Walker. So here we go. So So we're checking again if this is correspondence that assigns to a best-selling author the titles of books that they've written. We're checking if that's a function. So is this a function? Well, let's see. For our input, Toni Morrison, there are 1, 2, 3, 4, 5, 6 outputs. Actually, more than that. She's written a lot of books, but so there's more than one output. So nope, not a function. And this for Alice Walker, there's also at least 4 outputs. There is actually more than that. She's written a lot of books also, but so not a function, not a function. And why is it not a function? Well, because each possible value of the input, so at least for a lot of best-selling authors, they've written more than one book. So for each possible value of the input, there's not necessarily exactly one value for the output. There could likely be more than one value for the output. So not a function. So that's it for example number 2, it looks like. So hopefully that helped kind of get an idea of what this function business is about. Please do email me if you have questions. It's a little bit trickier online. I can't necessarily read your expressions and see if you're getting it or not. So if you don't understand it, tell me so that I can, help you figure it out. Maybe we can find another way that I can explain it, and we can get you understanding this material here. So thanks for watching, and all right, see you next time.